leading academic journals and policy forums such as the Quarterly Journal of Economics, the Journal of Political Economy, the Review of Economic Studies, the Review of Economics and Statistics, the Journal of International Economics, or Vox EU. She has expertise on Europe, China, and the Americas. She frequently speaks at academic conferences like today, as well as policy events at the World Bank, IMF, OECD, WTO, ECB, US Federal Reserve System, and the Bank of England, among others. I deeply appreciate that she accepted to deliver a conference today. The title of her talk is Multinational Firms and Global Innovation. So, Professor Manova, thanks again, and the floor is yours.
Well, thank you very much for this generous introduction. Let me just make sure you can hear and see me all right. If there are any issue at all with the slides, just let me know. And please feel free to interrupt with questions. I don't see you, so just feel free to speak up. This is joint work with Anna Gompert, who recently moved from the University of Munich to University of Tübingen, Monika Schnitzer, who's still at LMO Munich, and a fantastic PhD student in Munich, Christina Rajan. What motivated us to think about these questions is the mere complexity of global multinational activity. Multinationals today are at the heart of two fundamental globalization trends. One is the fragmentation of production across firms and countries, and the other is the internationalization of innovation, of technological progress. So multinationals are uniquely positioned because on the one hand, they manage very complex cross-country production networks. Some of it is within firm boundaries, transacting with affiliates they set up abroad, and some of it is across firm boundaries with independent partners. But at the same time, multinationals also conduct the vast majority of global R&D, and they're often looked to for transferring technology and know-how basically from developed to developing countries. And so it's interesting to think about how they organize their production and innovation activity because of the implications for policy design. In developed countries, there are some concerns about knowledge expropriation. In developing countries, on the other hand, there's a desire to essentially stimulate local innovation, but also enable adoption by facilitating FDI activity. So when you think about optimal policy design, this has bearings for how you think about investment policies and innovation policies together. From a global perspective, kind of abstracting away from the decisions that developed or developing countries face, we care about global growth. And so that's both about where the innovation frontier is, but also, inequality across countries and catch up. So with that kind of backdrop, multinational activity is quite well understood when you think about production patterns, but we know a lot less about innovation. And so in this paper, what we try to do is essentially think about the joint production innovation decisions of multinationals. And by way of motivation, multinationals increasingly offshore innovation. We're used to thinking about multinationals doing all of their R&D at their headquarters, typically in rich countries, and then offshoring low-skill intensive production stages abroad. But increasingly what we see is that there are foreign innovation facilities. So this is an example of Mercedes-Benz, a leading car manufacturer in Germany, that opened up an R&D lab in Seattle. This was primed to be a new digital hub for cloud computing and various services. What's interesting is that multinationals are increasingly offshoring innovation, not just to rich countries like the US, but also to emerging economies. So here is BMW, another German car manufacturer, who for a long time had been offshoring production to China, but actually not long ago also set up a large R&D center in Shanghai. And this was not meant to do something low-end. It's quite advanced. So they're focusing on autonomous driving, automotive design, and digital services.
I'll tell you about China.
So what we want to understand in this paper is basically how multinationals jointly organize their global production and innovation. The first thing we do is establish some new facts. we have very interesting data for German multinationals. Germany is a great context because it's the third biggest exporter, it's a major origin of foreign direct investment, and it is of course also a global innovation leader. Typically, when we study innovation, we are constrained to using data on R&D. And R&D records are spotty at best, and they don't really capture the success of innovation. There may be also various tax issues. And so R&D data is either not available or problematic. And here we're able to use detailed data on the global network of production affiliates for German multinationals and match it to information on the patents that German multinationals have filed. So the German FDI data is called MIDI, and the patent information comes from PatStat. So this essentially allows us to document some new patterns. Motivated by these facts, we then built an integrated model of multinational production innovation, where they're heterogeneous firms, and they choose jointly the location and scale of their manufacturing and two types of innovation activities. So we distinguish between basic innovation and applied. And we think of basic innovation as something that you need to do today in order to enable the future success of applied innovation. So in some sense, think of basic as increasing the present discounted value of a future stream of profits, whereas applied is something that gives you immediate profit gains. And the key ingredient in the model will be that there are some synergies when there's some cost advantages when you collocate applied innovation close to production. So think of it as the production floor managers being able to tell the R&D department, these are the kind of improvements we need. Finally, we're going to go back to the data and provide some reduced or empirical evidence consistent with the model predictions. And there we can exploit several dimensions of heterogeneity. So we'll exploit the variation across multinational firms in terms of their size. We'll think of that as a proxy for productivity. We'll look at the variation in activity across countries and patent technology classes within firms. And we're also going to make this distinction between basic and applied patent types. So what do we find? So here's a summary of the results, both sort of theoretical and empirical. I'd like to flag four main results, and the top two are about the variation across firms. The bottom two are about the variation across countries within multinational firms. So first, thinking about across firms, we see that bigger, more productive multinationals are more likely to innovate. They're more likely to hold patents. And conditional on innovation, they have more patents of higher quality. I'll say more about the data in a moment. Quality in this literature on innovation is typically measured by patent citations. So how many other future patents have cited your innovation? Secondly, when you look at where multinationals do their innovation activity, bigger, more productive multinationals are more likely to offshore innovation. And when they do innovate patents abroad, they are active in more countries, both with and without production affiliates. Now, thinking about the variation across countries within firms, right? So these are progressively more stringent exercises in a way, because when you look within a firm across countries, you can condition on many firm attributes and think about what are the country characteristics that predict innovation activity. So what we see is that multinationals are more likely to innovate and to innovate at higher intensity in terms of more patents and more cited patents in countries with revealed comparative advantage in a given technology class. So this is very similar to how we think about revealed comparative advantage in production. You want to offshore low skill intensive tasks to low skill abundant countries. Here we'll have a novel measure of revealed comparative advantage in innovation, which is based on observed patent activity across countries and different patent technology classes. You can think of technology classes sort of as a sector. There is a bit of a mapping between production sectors and innovation patent technology classes. And then finally, when we distinguish between basic and applied innovation, we see that offshore applied innovation is much more likely to be co-located with production than offshore basic innovation. I'll be brief about where we fit in the literature. But I realize that this audience is very mixed, and I really hope that this is the kind of paper that actually will be interesting for people that come from different backgrounds, because it sort of does cross across several fields or several areas of this literature. So first, there's been a lot of interest in the global organization of multinational production, where this literature first started by thinking about the reason why you produce abroad, horizontal versus vertical FDI, and so on. And later started thinking about how we draw multinational boundaries, hold the problems within the firm. And essentially in this paper, where we go beyond is to incorporate what we do know about MNC production structures into a model that has innovation activity as well. When you think about prior work on the innovation of multinationals, there's been a lot of interest in the role of institutions in intellectual property rights protection. So a few papers showing that countries that have stronger intellectual property rights standards attract more inbound FDI, presumably because multinationals are concerned about their knowledge being expropriated. In the more recent literature, there's been more interest in how innovation by the headquarters is related to the production affiliate network. So a couple of papers showing, for example, that there's some complementarity between innovation at headquarters and production abroad. And if foreign production conditions, offshoring conditions become more attractive, a firm is able to offshore more production, and it uses some of the cost savings to do more R&D at home in the headquarters. There's also some evidence that R&D conducted at the headquarters improves the productivity of the entire firm. So not just at headquarters, but also, productivity spillovers to affiliates. What we do to contribute to this literature is to actually think about offshoring innovation as well as production, and thinking about whether or not you co-locate the two or you split them up. We also move away from the focus on R&D to think about patents and think about this distinction between basic and applied innovation. And then finally, moving beyond the international literature, there's actually a vibrant literature on innovation activity. A lot of that literature is focused on innovation within the US. One reason for that is that the US Patent Office has some unusually rich information about patent applications. And so in this literature, they're interested in the causal effects of patenting on subsequent firm productivity, performance, or subsequent firm innovation. And for that, identifying causality exploits this additional information in the US Patent Office. So for example, there you see both successful and failed applications. In some other work, by the way, that I'm doing with Chinese data, we're looking at how Chinese firms take out US patents and how this subsequently improves their export performance. And there we use the same identification strategy as in this innovation literature. More recently, there's been some focus on whether or not production and R&D are co-located within the US. So essentially, but kind of separate from the patenting literature. So essentially what we're doing here is making these questions more global in focus and think about multinationals innovation worldwide. This also allows us to think about the interdependence in innovation activity across countries. And that has been a policy interest. So as much as developing countries would like to attract more inbound FDI or local innovation capacity, rich countries are concerned that when firms from developed countries offshore innovation, that might be to the detriment of innovation activity at home. And I think we're going to have a very positive message here that there is not just interdependence, there's in fact complementarity in innovation worldwide. So here's a roadmap. I'll say a little bit more about the data and introduce the stylized facts. I will probably be brief on the model. I'll show you the slides, but I'll try to stay focused on the main ideas and mechanisms rather than getting bogged down in derivations, and then save time for the empirical evidence. Can I just ask, shall I go for the full hour, or is it better to do kind of 45, 50 minutes and then have some time for Q&A? I'm happy to do either, whatever you prefer.
I think it's better if you stay like 45, 50 minutes and then we have time question for Q&A. It's okay?
Yeah, I
Thank
agree.
you.
Perfect. Thank you. Let's do that. Okay, so the data. So we are very fortunate to get access to two data sets for German firms, German multinationals. The first one is MIDI. It has information on about, well, it's the universe of German multinationals, which is about 15,000 that operate affiliates in about 200 host countries. And you have the balance sheet information of all the parents and foreign affiliates. The average multinational is active in about 3 locations with, on average, 4 affiliates. Now we can match this data to PatStat. So this is information on all the patents owned by firms globally. There is this notion of a patent family. Basically, if you have a patent, you can submit it to several different patent authorities. The leading 5 are the European one, the US, Japan, South Korean, Chinese one. And so PatStat is this global data set. And a patent family is basically a patent that has been filed, potentially across multiple jurisdictions. There's a lot of rich information about each individual patent. I'll tell you about that in a moment. In order to be able to compare kind of apples to apples as opposed to apples to oranges, we do what's standard in this innovation literature and focus specifically on patents filed with one jurisdiction. So we're going to focus on patents filed with the European Patent Office. But this being German firms, there's a very small minority of German firms that file elsewhere and not in the European Patent Office. So there are no issues of representativeness. Okay, so what are the relevant patent characteristics? We know where patents were invented. So for each patent, you see the location of the inventor. Outside of Germany, the top 5 hubs for German multinationals are going to be the US, Austria, France, Switzerland, and the UK. But notably, China and India have made it into the top 15 in recent years. For each firm, we have the global network of production affiliates, and essentially this allows us to map out countries where you operate both a production affiliate and your innovating patent. So we're going to call that co-location. And countries where you don't have a production affiliate, but you might still be innovating patents, so not co-located. For each patent, we have information on backward and forward citation. So what is that? Whenever you submit a patent application, you cite other patents leading up to your invention. And these are very common measures that people use in this literature. So you look at a 5-year forward citation record to get a proxy for how important or high quality a patent is. And then looking backward, who do you cite in your own patent application contains information about the patent type, basic versus applied. So if you cite directly a scientific journal, or you cite at least one patent that cites a scientific journal, you're basically, not more than 2 steps removed from fundamental science. That's kind of the premise in this literature. And we're going to call you a basic patent. Whereas if you're not really citing scientific journals, you're doing something that's much more applied and relevant to production processes rather than foundational. And so on average, a bit less than 30% of patents are basic. Okay, so a lot of multinational patent activity across countries. So this is just a plot, a scatter plot. On the horizontal axis, you have the average GDP per capita of a given country over the period in our panel. And on the vertical axis, you just have a patent count. So, this being for German multinationals, of course, Germany comes up on top. But you do see that it's not just, in the US and Switzerland that German multinationals innovate, India and China, Slovenia, Hungary, and whatnot. So, 3 stylized facts that motivate our analysis. Fact 1, multinationals innovate actively and very frequently abroad. Overall, 30% of German multinationals have at least one patent filed with the European Patent Office. Of those parents that do have patents, 43% innovate abroad. So 43% file at least one patent with a foreign inventor. And if you move to the patent level, that means that about 14% of patents were invented abroad. So that's fact 1. Fact 2, multinationals innovate in multiple locations. So it's not just that you choose whether to innovate at home or in one other country. You very frequently mix. So this is a Venn diagram, right? So you see how 57% of German multinationals, innovate only at home. Of those that innovate abroad, right, 7% invent patents both in Germany and in another location where they do have an affiliate, so that's offshore co-located. 17% innovate at home and in another location without a production affiliate, not co-located. And about 16% do all three types of locations. And there's some data disclosure issues, so I'm sort of not allowed to tell you that each of these here are sort of 2, 0, and 1%, but they're basically not important. So there's very few firms that innovate only abroad and not at home in Germany. So that's fact 2 for the firms. I just wanted to highlight a couple of the numbers on this slide. Offshoring patterns vary by patent type. So just look at the very bottom bullet points. On average, basic patents have a 23% probability of being offshored. For applied, that's only 15. So basic are more like to be offshored. And basic are less likely to be co-located with a production affiliate compared to applied. These numbers don't look too different here, but when we go to the more rigorous empirical analysis, they will be more stark. So fact 2 is multinationals innovate in multiple locations, both with and without affiliates. And then the last fact is, perhaps not surprisingly, but it's something that we simply didn't know before. So it's the first time we can show it in the data. Larger multinationals innovate more. So on the left-hand side, you see that bigger multinationals hold more patents. And on the right-hand side, you see that bigger multinationals hold more cited patents. So we would interpret that as higher patent quality. And what we have done here is essentially bin firms into 10 bins based on size. Okay, so with these 3 facts at hand, let me go to the model and try to highlight the main ingredients, mechanisms, and results. So what's the setup? Well, it's an integrated model of multinational production and innovation. And we want to have at least 3 countries. So we'll think about West as the home country, East, and then South. They're monopolistically competitive heterogeneous firms with a productivity draw, and there are 2 types of labor. Some labor is only involved in manufacturing, in production, and some workers are only involved in innovation and R&D activity. So we will be keeping track of wages for both types of labor. We want to think about the problem of a Western firm, which is considering becoming a multinational, producing and or innovating in East or South. And of course, the firm is going to kind of make these joint decisions over the location and scale of its production innovation activity to maximize global profits. We want to have some interesting trade-offs in the model, in this decision-making. And so we'll let South have a comparative advantage in production. So we need an assumption on production wages being lower in South than in East and West. They can be the same in East and West. That's irrelevant as long as South has a comparative advantage in production. And for innovation, again, just to keep things interesting, we're going to assume that East has the comparative advantage in innovation. So what matters is that, East has lower innovation wages than West. South may or may not. The production technology is fairly standard in that they're increasing returns to scale. There's some fixed costs to headquarters or to doing FDI abroad. Marginal production costs depend on the firm's productivity draw fee as well as the wage, the production wage, where production takes place. So in principle, this is a multidimensional firm problem, which can accommodate many different multinational patterns. So we're going to make 2 simplifying assumptions in order to get relevant predictions in a very transparent and tractable setup. So the first assumption is that there are no trade costs. And the second assumption is that there are very strong economies of scale in production. So these fixed costs per affiliate are large. Essentially, what these 2 assumptions are going to bias is that conditional on becoming a multinational, firms have an incentive to concentrate production in one location. And then from there, they can sell worldwide, there are no trade costs. You can relax that. You can have production in several locations. Everything I'll show you today is going to go through. You're just going to have to keep track of a more complex geography. And so when we think about a Western multinational, essentially, we're going to be thinking of a Western multinational that concentrates production in South because production wages are low there and uses it to serve all markets. Innovation technology is where, the action is, and that's what we consider more interesting. We'll make this distinction between 2 types of innovation, basic and applied. So applied innovation increases profits today and forever by lowering marginal costs. This is isomorphic to improving product quality or appeal. We introduce it simply as a lower marginal cost. In contrast, basic innovation is essentially an investment in the future. So it raises the present discounted value of the expected future profits, formally speaking. You can think of that as a prerequisite for successful applied innovation in the future or as a lower death rate. So let me just fix ideas, give you an example. Take pharmaceuticals, which is an important industry for Germany. Today you might discover a new chemical reaction. We would consider that basic innovation. You don't really know what you're going to do with this reaction, but you have a new way of doing something. And maybe tomorrow, this will actually allow you to do some successful applied innovation. And that can be process innovation in the sense that you have a more efficient way of producing things. For example, less gas is dissipated when you're producing some chemical. Or it can be a product innovation where this new chemical reaction allows you to put together a new combo vitamin pack, so essentially a new drug formulation, right? The way we're going to operationalize this in the model is going to be a static framework. And so essentially we'll work with the per period equivalent of profits and amortized costs. So what are the trade-offs here? Firms want to choose the innovation quality or quantity, however you want to call it, in each of three locations, home, west, so home is west, east and south, in each R&D type, basic and applied. So in principle, you're looking for 6 choices here over innovation decisions. Important for us is there's going to be asymmetric complementarity in the returns across innovation types and locations. Okay, so applied innovation lowers marginal production costs and it's additive across countries. So you did a bit of it applied here, there, and there. You add it all up, and this is how much this lowers your production cost. This is how much more productive it makes you. Basic innovation is going to essentially amplify expected profits. So it's going to be a multiplier in a static formulation. It's going to be a multiplier on your variable profits. I'll show you the firm problem in a moment. It will make more sense there. Innovation costs are going to be additively separable across types and locations. So there is a fixed cost component to innovation activity and a variable cost component. As usual, we're going to assume that innovating abroad is more expensive than at home. And you can think of that as the extra cost of communicating, monitoring, providing incentives. For basic innovation, costs don't depend on co-location with production. But for applied innovation, they do. And in particular, you're going to have lower fixed costs of applied innovation if you can co-locate it with production. So the way to think about that is that there's some synergies when scientists are close to production floor managers. The managers can tell them what problems they have and essentially ask for a practical solution that they can implement right away. And when the scientists have come up with some applied innovation, then they can easily do the beta test runs or the implementation on site. So that's the sense in which applied innovation synergizes when it's co-located with production. For basic innovation, that doesn't matter. You're just creating something that's going to allow applied in the future. And so if we think about the choice of a Western multinational firm, the relevant comparison is that for basic innovation, the fixed costs are going to be lowest in the West at home and higher abroad, but regardless of where you go. For applied innovation, the fixed costs are actually going to be lowest if you go to South because that's where your production affiliate is. They're going to be higher if you come back home because you don't produce at home anymore. And they're going to be even higher if you go to the East. You don't have a production affiliate there, and it's not at home. You have the extra communication costs. Okay, so here's the firm problem. The firm is going to choose its optimal location and scale of production and innovation. In a full-blown model, you're going to have selection into multinational activity above a certain productivity threshold. This is quite standard in this literature because of the fixed cost of setting up affiliates. We're going to focus on Western multinationals with a silent affiliate. And so then the focus becomes on their innovation strategy. And such a Western-based multinational may innovate at home in the West and or offshore co-located with production in the South and or offshore not co-located with production in the East. And the one kind of, we think, really interesting thing that comes out of this framework is that there is interdependence between production, basic, and applied innovation. And for that reason, it might become attractive to offshore multiple activities, even if it's not worth it to offshore just one of them on its own. Right? So this interdependence can actually really change the final decision. This is the firm problem. Let me break it down for you. First, the firm is maximizing profits by choosing essentially a vector of 8 variables. This is the price of output, the quantity of output, and then this vector of basic and applied innovation in each of the 3 countries. So 6 innovation choices in total. Profits are essentially variable profits, so sales minus variable costs minus fixed costs. Basic innovation increases variable profits. This is the equivalent of sort of a higher present discounted value of future profits. Variable profits themselves are sales minus total variable costs, and this is where applied innovation enters. This is your output quantity X, your productivity draw B, and all of your applied innovation is going to essentially amplify your productivity draw, in other words, lower your marginal cost. Then finally, you have a bunch of fixed costs. You have the fixed costs at headquarters of the foreign production affiliate, and any innovation costs you incur are additively separable. So remember, those are in multiple locations J and the 2 R&D types. So that's the firm problem. So the way we solve it is in 2 steps. You first figure out the optimal production strategy conditional on innovation. So assume you know the innovation levels. Well, that is as if I've already given you a production function with clear marginal cost and fixed costs. And you just need to figure out what is your optimal price and quantity. So the solution to that problem is quite familiar. Firms are charging a constant markup above marginal cost. And this implies that applied innovation directly enables lower prices and therefore also higher revenues and profits. You don't see basic innovation anywhere here, but it won't matter indirectly because the decision over basic and applied innovation is joint, and there will be complementarities between the 2. But assuming an innovation strategy, we know what optimal production will look like. So therefore, we can now solve for the optimal innovation strategy. So the reduced form problem for that essentially plugs in the values for optimal pricing and quantities. This is what it looks reformulated. And essentially, this top line are those variable profits, which are a function of some aggregate demand and price conditions, your total basic innovation, your total applied innovation, which lowers your marginal cost, and your productivity draw. And the costs are the same as before. So the takeaway is that the profit function is supermodular with respect to productivity, basic and applied. In other words, this is the same about second derivatives. Second derivatives are positive across the board. So another message is their innovation will be interdependent across countries. When you look at applied innovation, it's interesting. Whether applied innovation in 2 countries is complementary, substitutes, or independent actually depends on this elasticity of substitution sigma. There is a knife edge case in which it's independent across countries, given estimates in the prior literature of sigma at around 4.5, and also given our use from evidence, we seem to be in this happy scenario where applied innovation is actually complementary across countries. If you do more in one country, you're going to do more in the other. Basic innovation is not directly interdependent across countries. It becomes complementary across countries because it is complementary with applied. So here are the 4 model predictions, and then I'll show you the empirical counterparts to those. So 4 propositions. First, more productive multinationals are more likely to innovate and to innovate more intensively in terms of those innovation quantities in the model. Why is that? Well, profits are supermodular. The second derivatives are positive with respect to productivity and basic innovation, productivity, and applied innovation. Secondly, more productive multinationals are more likely to innovate abroad. And when they do that, they're more likely to offshore to multiple countries. Why? Well, we know that there are fixed costs to offshoring innovation. And so you get this classic economies of scale argument that multinationals that are bigger, more productive operate on a bigger scale. They're more likely to profitably offshore innovation. As a corollary of that, we know that multinationals that are more productive are also more likely to offshore innovation to both countries with and without affiliates, right? On the margin, if their per country innovation fixed costs. As a multinational, you're more likely to innovate in more locations. Some of them will have a production affiliate, some of them will not. And so if you're more productive, you have a bigger chance of essentially mixing and matching innovation locations. Third, and now we start looking at the variation across countries within a firm. For multinational, when it thinks about where to locate innovation, it's more likely to go to countries with lower innovation wages. Why is that? Well, profits are submodular in inventor wages and innovation quality. Just like we offshore production where it's cheap, we're going to offshore innovation where it's relatively cheap. An interesting corollary of that is that you can extend the model to a framework with multiple sectors and allow countries to have comparative advantage in innovation in different sectors. So make the innovation wage not just country specific, but potentially country sector specific. So just like we talk about comparative advantage in production across countries and sectors, we can talk about comparative advantage in innovation across countries and sectors. And in such an extension of the model, you'll get the prediction that multinationals are more likely to innovate and at higher intensity in countries with a comparative advantage in their technological area. Finally, everything I've shown you so far, the first three propositions hold for both basic and applied innovation. And in the data, we'll likewise show you results for basic innovation, applied innovation, or just any innovation. The last proposition makes this distinction between basic and applied. And in particular, we find that offshore applied innovation is more likely to be co-located with production than offshore basic innovation. Why? Well, because of the assumption we made. This result essentially was built in based on the motivating facts. We assume that there are cost synergies between production and applied innovation that are not there for basic innovation. So one way to think about that is that when a German multinational wants to offshore basic innovation, it's more likely to go to the US or Switzerland because they are the innovation leaders. And for basic innovation, you just go where it's best, regardless of what production wages are. And if the US and Switzerland have the comparative advantage in basic innovation, that's where you're going to go. For applied innovation, you might be more likely to move, let's say, to China or Thailand or India because you want to try to collocate applied innovation with production. And so you're paying attention to both production wages and innovation wages. So you're more likely to locate applied innovation where production is also attractive. Finally, let me show you the empirical evidence. I'll take another 5 minutes max, and then we can open it up to Q&A. So the estimation approach is actually very straightforward. We're going to run OLS regressions at 3 different levels of aggregation. I like mnemonics, so the subscripts here are supposed to be intuitive. So first we're going to run regressions at the firm year level, FT. And essentially, as an outcome of interest, we'll look at whether or not you innovate, conditional innovation, how many patents you have in how many locations, what is the patent citation record. And on the right-hand side, we're interested in how this correlates with proxies for productivity. In multinationals' data is common. We don't have enough information to construct proper OLI package type measures or ACR type measures of productivity. So the common strategy is to use global sales to proxy firm productivity or firm size. So I'll show you results for global sales, but we do have robustness checks looking at sales per worker, which look very similar. Then we're going to unpack this and look at the variation across countries, host countries, and technology areas within a firm. So A is for technology areas. So the fact is firm, technology area, country year. And at that level of aggregation within a firm with firm fixed effects, we want to see whether innovation activity follows countries' revealed comparative advantage in innovation by technology class. So I'll tell you a little bit more about that measure in a second. And then finally, we can also move to the most granular data. We'll look at the patent level, so firm patent level, and essentially ask whether applied innovation is more likely to be co-located with production. So here the outcomes of interest will be indicators for whether or not you have an affiliate in the same country where the patent is invented. Let me clarify where identification comes from. So we'll include a stringent set of fixed effects that absorb a lot of unobserved firm characteristics and macro conditions. So for example, we're going to have sector fixed effects. When we're looking at the firm level, these correspond to 23 two-digit sectors production activity. When we're looking at the firm technology class area or the patent level, then the sector is essentially the technology area, and there are 34 categories. So these kind of sector fixed effects are going to absorb cross-sector differences in production factor intensities, the technological scope for offshoring production or innovation, as well as any of these parameters in the model that don't depend on sectors but might in practice. Things like what is the scope for innovation, production cost synergies, and so on. We're also going to have a full set of country and year fixed effects to absorb various supply and demand conditions or cross-country differences in institutional environments like wages, taxes, and so on. And then finally, where needed, we'll have the firm fixed effects. And then that means that we're conditioning on unobservables such as firm productivity or management practices and such. Okay, how do we measure countries' revealed comparative advantage in innovation? Well, it's actually going to be a measure quite intuitive to trade economists because it's constructed similarly to how we would measure revealed comparative advantage in production. Only instead of looking at what share of exports are in a given sector, we'll be looking at what share of patents invented in a given country are in a particular technology class. So our RCA measure does precisely that. So for each country, we're going to count how many patents were invented there in a given year, and how many were in a particular technology class, like the ratio of the two. And conceptually, we think of that as being inversely related to inventor wages in our framework. The details of the construction are here on the slide, but let me skip that in the interest of time. So some examples, Germany comes on top in terms of organic chemistry, electricity, energy, transportation, cars. So this all kind of lines up with priors. The US scores really highly on medical technology and IT. Switzerland does well on measurement and precision instruments, medical technology. So clearly these revealed comparative advantage metrics make intuitive sense. So let me show you the evidence. This is the first proposition. More productive multinationals are more likely to innovate in that they're more likely to hold any patents. That's column one. And conditional on innovation, they hold more patents that have higher citations on average. So they're higher quality, more impactful patents. We can also do this separately for basic and applied innovation. The elasticity is actually quite comparable here, except it seems like the size premium is much higher for the incidence of basic innovation than applied. But conditional on innovation, the other elasticities are similar. So that's fact one. Proposition one, in some sense, confirms it. Proposition two, this was fact three, which is now more rigorously done in proposition one. Proposition two, where do multinationals innovate? Do they offshore patenting activity? Well, more productive multinationals are more likely to invent patents abroad, and conditional on doing that, they're active in more countries. So here, each coefficient, each cell comes from a different regression. In the first row, we are regressing a dummy for any offshore patent activity on global sales. And these positive coefficients tell you that bigger multinationals are more likely to offshore patents overall, or if you break it down, basic applied. You might say, is this just because multinationals are more likely to do more everywhere, both at home and abroad? No. We can also look at the ratio. So what ratio of patents were invented abroad? That also increases strongly with size. Okay. We can ask, how many countries do you invent in? Well, bigger firms innovate in more locations. And some of those, of course, might have affiliates or not. So you might wonder, what if you condition on the number of affiliate countries? Well, given that bigger firms are more likely to operate affiliates in multiple locations, of course, the point estimates here are going to go down. But what we find intriguing and consistent with our model is that the number of affiliate countries is much more predictive of how many locations you have applied innovation than basic innovation. This is indirect. I will later go to the co-location results more cleanly at the patent level, but this is certainly consistent with the story that you're more likely to co-locate applied innovation with production than you are basic. Okay, As a corollary, I mentioned this thing about more productive multinationals being more likely to offshore to locations both with and without. So here we have done an ordered logic. And essentially, firms that do both collocated and not collocated patenting are bigger. Okay, so that's the main takeaway from this slide. I'm not going to belabor the point. All right, let's move on to propositions 3 and 4. We look at finer levels of disaggregation. So here now we are unpacking the data. And now the unit of observation is a firm, technology area, host country. So we're asking, and I'll show you results both just with technology area fixed effect or also firm fixed effects, which are the specifications we find most informative within a firm across countries. What you see is that multinationals are more likely to innovate in countries with revealed competitive advantage in their respective technology area. And this is regardless of whether or not the firm has an affiliate in that country. And it's also not because bigger firms are somehow systematically choosing different locations. So even conditional on firm size, this revealed comparative advantage innovation comes out very strongly. The first 3 columns look at the number of patents that you invent in a given location. The last 3 columns essentially add up the citations across these patents. So it's something that they call citation weighted patent counts, just to incorporate information on the quality of these patents. We've done it separately for basic and applied. It all goes through as expected. The final result goes to the most granular level of the data. The unit of observation now is a patent. And again, there are regressions both with and without firm fixed effects. The one with firm fixed effects we find a lot more informative because they can control for various firm attributes and compare like for like. And so within a firm, what we're looking at here is whether applied patents are collocated with production or not. The outcome variable is this dummy, yes, no, I have a production affiliate in the country. And we find systematically that applied patents are disproportionately likely to be invented in countries with a production affiliate. Again, this is controlling for firm size in case you think that different firms are somehow systematically choosing different production and innovation hubs. So let me stop here. Multinationals manage very complex global operations that span production and innovation decisions across multiple countries. What we have seen here is that there appears to be country comparative advantage in innovation. Good news for policymakers, I think, is that there appear to be cross-country complementarities in innovation. And there are also synergies between applied innovation and production exceeding those potentially between basic and production. I think looking forward, what are the big questions on the table? We care about technology frontier and knowledge transfer, and the implications for optimal policy design. But I do want to highlight that when we think about policy design, it's not about national investment in innovation policies. I personally am a big believer in the scope for multilateral cooperation. And it's tempting to call it deep integration, although that can be misinterpreted. What I mean is that it's not just about cooperation on trade barriers. It is about cooperation on innovation. And if you think about the climate challenges that we face as a world, that's very much related to that. There seems to be complementarity innovation across borders. And to me, that suggests that there is scope for multilateralism. So let me stop here and open it up to questions.
Thanks, Professor Manuel, for your wonderful presentation. Now let me see if we have any question. Any question?
Hi, good afternoon. Well, I have a question that probably you have answered this question, but because I read something a little bit related, but not the same, of course, is that I read things related to the fact that when companies are patenting in many countries, then typically they either have the objective of a market-seeking strategy, or, for example, this also happens for more radical innovations. When a company has a much more radical innovation, it is interested in protecting this innovation in much more patent offices all over the world. Then I was wondering if this has some relationship with your results, because, for example, in the case of the strategy of market seeking, then probably the strategy of patenting because of market seeking is very much related to collocation of production at the same time, to be closer to the final consumer. And this is probably more related also to the applied patenting, for example. Then maybe there is also this strategy of market seeking related to collocation of production and at the same time related also to applied patents. I don't know. This is something that I just thought about when I was listening to your presentation. Or if there is some room also for the more radical innovations that you are capturing through the citations. But maybe the citations, if the citations can proxy also for radicality, maybe you can also use them interacting some of the other regressions to try to capture this. I mean, in a regression in which the citations is not the dependent variable, but is a variable that appears crossing something else in maybe the other regressions to try to capture something about, if there is something about, I don't know, this other strategy of protecting more radical innovations. And something for policy that I don't know if it's possible to derive from your work or not, we will see this probably in the future, is that can we think or tell to developing and emerging economies that because of the behavior of multinationals, there is going to be a high concentration in technological fields, innovation in specific countries, because if you have the comparative advantage in Taiwan, all the multinationals in this technological field, they are going to know you have this comparative advantage and they will do all the innovation there. And we will end up with this type of structure of innovation of multinationals in emerging economies.
Thank you. This was fantastic. Thank you. You've made so many interesting observations and suggestions. So I'll pick up on a subset. I'm very interested in understanding where firms file their patents. What we have done in this project here is think about where they invent, so where they innovate, but not about where they file patents. And as I mentioned, there are multiple patent authorities. In principle, when you file a patent, say, with the European Patent Office, this patent is only valid in the European jurisdiction. It's not recognized in the US. So if you're doing market seeking and you want to protect your intellectual property in the US, you would then have to file the same patent also with the US Patent Office. So they're the big five, the US, European, Japan, South Korea, and increasingly China, where the consensus is that China has been on the rise in terms of numbers, but there are concerns about the quality of the patent vetting process in China. So the US, Europe remain kind of the leaders in that respect. So I think that there's a smaller literature thinking about the strategic decision where to patent. That has been done, I think, just for US firms, but I think it's interesting to put it in the context of exports essentially and global firms. This other project I mentioned that looks at Chinese firms speaks a little bit to that. So, but I'd like to do more in a follow-up project. So I'll mention both. This project with the Chinese firms, we look at where Chinese firms, we look at Chinese firms which take out the patent in the US. And we have information on both successful and failed applications. So there's an identification strategy based on what examiner in the US Patent Office reviewed your patent and what their past examination history is. And so we can match this data to customs records, very detailed customs records for Chinese firms, which allows us to look at where these firms export by filing these aggregated product categories and countries. And so what's interesting is that if you think that they file with the US Patent Office just for market seeking, you would expect a rise in these firms' exports to the US. And moreover, this would be concentrated in the products that are actually, technologically related to the patent. We see a small rise there, but actually we see a much bigger expansion in export activity to the rest of the world outside the US. And it's mostly driven by products that are not in the same technology class as this US patent. And so in that paper, we have a story about signaling, where getting a US patent for a firm that comes out of an emerging economy like China, where there's a lot of asymmetric information, average quality may have been increasing, but there's just a lot of uncertainty about supply quality, right? Getting the US patent essentially provides a signal to foreign buyers that this is a solid farm. And this is a way to rationalize why exports increase to other markets, not just to the US, where you got the patent. And with some data work, we kind of narrowed down on two channels. You're signaling the capacity to produce high quality, but also that you're trustworthy, you're going to honor contracts. But that still doesn't answer your question, because a firm can file the same patent in multiple locations. So, for this Chinese paper, the way, we think it's signaling, because we can also condition on where else this Chinese firm filed the patent. So, if we see that exports increase to Europe after the American patent, it's not just because you got a European patent as well. I'm currently thinking of starting a new project, either with the German firms or with the Chinese firms, trying to understand why firms file the same patent in multiple locations, and whether it's about market seeking or there's something else strategically going on. So I don't have answers to you, but I do agree it's fascinating. It is poorly understood. We just simply don't know. I can also tell you that there is an international agreement, I forgot what it's called, but essentially, if you submit the same patent within 2 or 3 patent jurisdictions, but at different times, ex post, it doesn't matter. So basically, if the first of those is approved by the European Patent Office, then that start date is going to hold even retroactively for, say, the US office or Japanese office. So, so it's interesting to understand these strategic decisions. You mentioned something about preemption. So essentially, how much information you disclose to other potential inventors and imitators. And I think there is a literature on that in innovation. So if your product is really, really advanced, you're not really worried. Nobody can imitate you. You're such a front runner. So you patent right away just to protect your knowledge. If what you're inventing is more incremental, you might be concerned that you're disclosing enough information that, like, a close runner-up can quickly imitate and surpass you, because when you file your patent, you actually describe the invention quite detailed. So I think there are some models which predict that you need the innovation to be sufficiently big in order to patent early. Otherwise, you might wait strategically. So I know I didn't answer all your questions, and I also kind of went a bit off piste with a detour, but let me just reiterate that I think you brought up a few very interesting observations, and I think that there's a lot of interesting work that can be done in this direction.
Okay, thank you, Kalina. Now, Carlos Serrano from Egg Paris wants to ask you a question.
Thank you. Maybe my question is a bit weird, but so as far as I understand, there is an assumption being made that there is a centralized headquarters and all decisions are at the headquarters. There is no delegation problem. So my question is about maybe in the future to potentially relax that assumption. I mean, after all, we are talking about innovation and they're expanding into other countries. So for what people are doing in China to work, we have to delegate. But I was thinking of the possibility of one sort of conflict between headquarters and the affiliates in terms of the type of innovations that should be done. Like, so it is certainly possible that what affiliates want to do might not be, depending on how we compensate them, etc., might not be coincide perfectly with the headquarters. And as these companies expand, that might be an issue. So I would like to, to elaborate on this. So that's one thing. And the other one is more, there's another conflict of interest. But this one is instead of, so right now you have, firms, but these firms are also, they are German firms. So it could actually be the case that if we add to the country Germany, and we have an objective function for Germany, it might be the case that there is a conflict of interest between what these German firms are doing in China and how good that is for the company, but that might not be for the taxpayers of Germany who might be subsidizing, these companies, right? So that's another conflict of interest. That would be more from a national security point of view. Germany is a country that has had these issues, I think, apparently. Those are the two things. Thank you.
Thank you. Perfect. Spot on. So on the first point, Yeah, I find these issues of organizational management, organizational behavior fascinating. So in our model, we have a reduced form version of this imperfect alignment of incentive, in the sense that the fixed cost of innovation is higher abroad than at home. And you can think of that as the extra fixed cost of communication, management, or aligning incentives. But that's imperfect because it's still, it's just a fixed cost. It could be a different kind of friction. So I completely take that on board. And I think these kind of organizational managerial issues are quite interesting in practice. One thing we could do, I've not thought about that, is there are indices of corporate governance across countries. There's going to be a lot of variation in governance across firms, though, even within countries. But at a minimum, what we could do is basically see if there's some systematic variation across countries in these innovation results based on indicators of corporate governance, creditor rights protection, that kind of stuff. Another thing I know, so I've worked in the past with data on US multinationals. In principle, everything I've shown you today can be done for the US. It's just that on this project, I was working with German co-authors who had the German multinational data. I thought that was pretty cool. In the US multinational data, for sure, you observe the ownership stake in a foreign affiliate. I suspect that's also the case for Germany. And maybe another idea is to look not just at corporate governance indicators across countries, but essentially degree of ownership stake across affiliates within a firm or across firms or something like that. And the argument being that if the ownership stake is higher, then presumably there's more aligned incentives in terms of corporate oversight and whatnot. So thank you for that. But the other point is highly relevant for policies, sort of from a national welfare perspective. We don't have anything direct to say to that, that's clear. We don't have a welfare exercise here. I can say two things. One is, at least our results suggest that there is complementarity between innovation at home and abroad. There is complementary innovation across countries because they enter multiplicatively into the profit function. So that is to say that if you offshore innovation abroad, you're not reducing innovation at home. And so overall, this is good news for firms, and therefore, depending on the model of profits you have, profit sharing, it might be good news for the taxpayer. More relevantly, though, I cited a few recent papers in this literature. I think there is actually one of them by Arkolakis, Costino, perhaps, I'm not sure, maybe Natalia Ramondo. They've been doing a lot of work on multinational production, and I do have a feeling that one of their recent papers, it's a theory piece, looks at the welfare effect of multinationals innovating at home and abroad. And I suspect that the result will depend on what assumptions you make, whether innovation at home and abroad are complementary or substitutes. But just taking a step back, I completely agree that these are the questions we should be asking. So from policy perspective, that's kind of what we need to know.
Last question by Frederick Bastinsky from August University.
What did I say about China?
Or I'm just Munich, actually. No worries, no worries. I'm still affiliated. So, hi, Kalina. Sorry you cannot be here. Thanks for a great talk. One thing that came to my mind, and I think it's related to the first point, actually, but it's a different twist on it. Having talked to many Danish multinationals, they have, in many cases, provided information that one of the reasons why they innovate or they do R&D abroad is to adapt the product to the specificity of the country. In particular, for example, when they invest in China, Chinese consumers are apparently less concerned about having high quality products, but they're more willing to have cheap, cost-efficient products that work. While in Western Europe, they might be more interested in having the highest quality. So you might have some quality differentiation there as well. So yeah, I think it's a different interpretation of what you define as applied innovation, but it's a different twist on it. So yeah.
Yeah, no, thanks. Sorry it's been missing. It would have been great to catch up there. I completely agree. So that is one way of thinking about applied innovation. So in our formulation, technically speaking, it lowers your marginal cost. It could change your quality level. I should say it is true though that we assume that innovation is just the benefits of applied innovation are additive across countries. And so in that sense, it's not a market-specific innovation. So if you innovate in China, and this allows you to produce more efficiently, you can in principle use this to lower your marginal production cost anywhere you produce. I think that, yeah, I think that relaxing these things is definitely going to give you richer predictions for what happens where. Something you mentioned got me thinking about product versus process innovation, even though it's not exactly what you had in mind. What you had in mind was efficiency quality, but kind of in the same vein. We did at a certain point, think about product versus process. Apparently, so the basic versus applied classification is based on backward citations, but in this literature, they do some semantic text analysis to identify product versus product process innovation based on patent abstracts. And at first we thought that would be pretty cool. We actually started out with a framework, with a model that had multi-product firms, and we thought of process innovation the way we think of applied here, something that lowers marginal cost or increases quality, whereas product innovation was something about the product scope, how many products you produce, how many new products you add. And we had some interesting predictions there theoretically, but when we went to the data, we didn't see stark differences in patterns between product and process. So in some sense, you could think of that as a 2x2 matrix. So each pattern can be categorized into basic, applied, product, process, 2x2 matrix. But somehow where the distinction in the data seemed to be was basic, applied rather than product, process. But I would think more about this. Can we do something about innovation that's relevant to the local market as opposed to also other markets? And I think that is also kind of related, like you said, to the earlier comment about where you take out patents and what are your markets. Thank you.
Okay, so thanks a lot again, Karina. I don't know, you are going to.
Thank you. It's really been a pleasure. I'm going to just step out for a moment and come back for the next session, but obviously please don't wait for me. And thanks for this. Again, apologies for not being there. I'll be logging in for the next talk.
Thanks a lot, okay? Bye.
I wore this before.
Where you been?
Nowhere. What are you burning?
Oh, nothing. Just some old blankets. You sure you didn't go past the bridge?
I said it could give you anything I'm lying.
Well, are you?
No.
Maisie, you're literally looking everywhere but here.
I said I didn't go past the bridge.
Maisie, can we start over?
I know, Claire. There are people out there who'll do anything to find me.
I'm not angry. So that means you don't have to be angry.
I'm not angry. I can take care of myself.
Hey, it's okay for us to depend on each other. That's what people do.
How would I know what people do? The only people I've spoken to in the past 4 years are you both. Besides, I'm not even a real person anyway.
What?
I was made from someone else. I'm not me.
The only you who ever was. What? Is that like really corny?
That's so corny.
Can we keep that between us?
Can't promise that.